Hi, I'm Guang, I'm 15 years old. In this lesson of Techniques and Applications of Definite Integration, we are taking a look at two different examples that we can try to solve. Right, how about let's start from the first example. And in the first example, you're going to see double integration over the region of x minus 1 square plus y minus 1 square smaller or equals to 2 and y is greater or equals to x. Well, your integrand is x minus y and dx dy. Right. First of all, we need to know what this boundary looks like, alright? So what would be so special about this boundary? Now, this boundary over here, you will first think about what is x minus 1 squared plus y minus 1 squared smaller or equals to 2. Or as a matter of fact, you can just first think about what if it is equal to 2, alright? So here's our origin, x-axis and y-axis. So that means this is a function of a circle. And this circle is centered at 1, 1. Alright, so this circle is centered at 1, 1. And its radius is square root 2. But if you realize, if it's at 1, 1, its distance away from the origin is perfectly square root 2. So that means it will pass through your origin, alright? So it will kind of look something like this, right? So next, your y is greater or equals to x. Y is greater or equals to x, which means you do have this line passing through the circle, alright? So this line passing through a circle and y is greater or equals to x, which means it has to be above this line. So your area for integration will be within this region here, alright? So that means now with this region, we know it, we can decide where are its boundaries from what and integrate to what. So if you choose to let it remain in its Cartesian form, yes, you can. But how about we try to change it into polar coordinates? Since this is a circle, so polar coordinates will be more easier to solve. Right, now in polar coordinates, you can choose to let the origin be where you integrate your polar coordinates. Or alternatively, you can think about what if I let this center of the circle be where I integrate from, which means you need x minus 1 be equals to r cosine theta and y minus 1 be r sine theta. So this will be what you want to substitute in. Alright, so x minus 1. Now if you think about it, x minus y is basically x minus 1 minus y minus 1. You just have to minus 1 and add a 1, right? So this will be the same as here, which means you can just use r cosine theta minus r sine theta. And dx dy becomes r dr d theta. Right. Now we take a look at your boundaries. So this boundary, what you will realize will be, since you take this part, the center, as where you integrate from, and your radius is square root 2, which means r you integrate from 0 to square root 2, alright? So from your center outwards onto your circle. And then the angle, theta. So theta, which means you have to, since you're starting from your center, which means you will have this angle over here until this angle here. Right, so how do we find this angle? Now, if you realize this is y is equal to x, and y is equal to x, your gradient is 1, and inverse tangent 1 is pi over 4. So you will have pi over 4 until, which means on the other side, you will also have pi over 4 below your x-axis. So you just have 5 pi over 4. Alright, so this is the kind of integration that you will have to solve. Right. Now, if you realize your radius and your angle are actually independent of each other, which means you can change it into iterator integration and solve them separately. Right, so this is essentially what you will need to solve. Alright, so for the second part, when you integrate r squared, you will have 1 over 3 r cubed. And 1 over 3 r cubed, you have to substitute in r is equal to 0 and r is equal to square root 2. Well, for your first part, cosine and sine, what will be so special about both of these? Now, of course, you can also directly integrate them already, since cosine, you will be having sine from your integration, right? And beware, this is multiplied on, so sine theta plus cosine theta. And then substitute in the values of pi over 4 and 5 pi over 4. Right, so this is what we will be seeing. And next, you'll have 2 square root 2 over 3. So, sine 5 pi over 4. Now, what is sine 5 pi over 4? So, since it is in the third quadrant, that means it is negative. So, this is negative square root 2 over 2. And then minus square root 2 over 2. Now, same thing goes for cosine. In the third quadrant, cosine is negative, so you have to minus square root 2 over 2. Well, then you have to minus another square root 2 over 2. So you have 4 of these square root 2 over 2's. Now, which means you will just have negative 8 over 3 if you manage to calculate it. Alright? So your answer for this question is negative 8 over 3. So essentially, what do we use for this question? Well, first of all, we started off by looking at what kind of a region we are dealing with. And once you know this region, we can change it to polar coordinates since it's a circle. And polar coordinates, you have to be aware where your center is. So after you determine where your center is, we can just start integrating with respect to whatever r and theta and your boundaries. Alright? So at last, your answer will be negative 8 over 3. Alright, so that's for your first example. Next, we'll be moving on to the second question. So, in the second question, you have a double integration x squared plus y squared smaller or equals to 4, x squared plus 4y squared plus 9 d sigma. So, the second question, the boundary, it looks a lot easier, but within the integrand it seems a lot more difficult. How about let's take a look at what kind of region we are dealing with. So an x-axis and y-axis. X squared plus y squared, that seems a lot simpler since your radius is 2 and it is centered at your origin. So a circle with radius of 2. Right, so this entire thing is what boundaries you are having. Alright, so how about we try changing it into polar coordinates perhaps? So when you change it into polar coordinates, I'm just going to separate these a little bit. Changing into polar coordinates, x squared is going to be r squared cosine squared theta. Y squared is going to be r squared sine squared theta. Well, 9 is just 9. Then d sigma, which will have r d theta. So r is from 0 to 2, while theta is from 0 to 2 pi, since it is an entire circle. Alright, so now that we have this integrand, well, of course we can take out 1 r squared cosine squared theta and 1 r squared sine squared theta to make an r squared theta. Alright, so this will be what you will have to solve. Now, of course, we will look at each of these terms separately. Now, integrate from 0 to 2 pi. The first term, r cubed, it will be 1 over 4 r to the power of 4. Your second term is also an r cubed, which is 3 over 4 r to the power of 4. But you might be wondering, well, isn't there the sine squared theta? But of course, when you integrate with respect to one variable, you will take all the other variables as constants. And x is 9 over 2 r squared. Well, you have to substitute in 0 to 2. Alright? So, now that we know this, of course, d theta. Now that we know this, we can substitute in the boundaries. Integrate from 0 to 2 pi. 4 plus, since when substitute in 0, everything is just going to be 0. So, plus 12 sine squared theta plus 18. Alright, so that means it's just going to be 22. So 22 theta, substitute in 0 and 2 pi. Well, for this part behind, what are you going to have? Since this is a sine squared theta, you are going to have to use your double angle formula for cosine, alright? So, using a double angle formula for cosine, you have to do plus 6, and then integrate from 0 to 2 pi, 1 minus cosine 2 theta over 2 d theta. And for your first term, you're going to have 44 pi. While for your second term, whoops, here you already have divided by 2, so you don't need to divide by 2 again, sorry. Right, so you're going to have minus 6 theta, substitute in the value 0 and 2 pi. And then minus 3, integrate from 0 to 2 pi, cosine 2 theta, d 2 theta. Alright, so now for this part, you can just substitute in the first part, which you'll get 44 pi, and then you have to add on 6 theta, substitute in 0 to 2 pi, and then minus 3, integrate from 0 to 2 pi. So you're going to have cosine 2 theta d 2 theta. Alright? So you're going to see 44 pi plus 12 pi, and then minus 3 sine 2 theta, substituting the value 0 to 2 pi. The first two parts you get 56 pi, while your last part is just 0. Alright, since sine 4 pi and sine 0 are all 0. Right, so your answer for this question is 56 pi. And the processes are pretty similar. You determine your region, and from a region you determine your boundary. From boundaries you can determine what kind of integration you have, and with the kind of integration you can then just pretty much start integrating and solving them. And after you solve them, you just get your final answer. So in this case it is 56 pi. So the methods for both questions are pretty similar. You just have to be aware of what kind of coordinate system you want to use and all of its boundaries. Alright? So I hope for this lesson you've covered everything so far. I will be ending this here, and thank you for your watching.